Hi friend, welcome back to Rama's tutorials for GK. This is Rangraju from Tumkur. Dear friend, today we are going to discuss about carbon and its compounds. Now, let me know about the basic information of carbon. Dear friend, carbon, the Latin term of carbon is carbo or coal. It is a chemical element with symbol C and atomic number 6. It is one of the non-metallic and tetravalent. That means making 4 electrons available to form covalent chemical bonds. Then it belongs to a group 14 of the periodic table. Then this carbon occurs naturally, that is 12C and 1213C, that is stable, and 14C is a radionuclide. So these are the isotopes of carbon. And then allotropes of carbon are graphites, diamond, etc. Then these carbons appears black. Diamond is clear in color. And then period, the carbon, already you know that the carbon belongs to second period and 14th group, second period and 14th group, and the black is p block element. Here in non-metal, this is the, that is carbon is one of the reactive non-metals and sometimes it is considered as a metalloid. Then its electronic configuration is found to be 1s2, 1s2, 2s2, 2p2, 1s2, 2s2, 2p2, or it is also written as helium. It is also written as helium, that is helium 1 2s2 2p2, 2s2 and 2p2. So this is the electronic configuration of carbon. Then electrons per cell, that is 2 comma 4. So this is about the basic information of carbon. Now let us discuss about some more important factors, that is related to the carbon and its compound. Dear friend, let us know about the one of the peculiar character of the carbon, that is covalent bond, and then bonding nature of the carbon. Now in this video let us discuss about covalent bond. Dear friend, covalent bond means a covalent bond. It is also called molecular bond. It is also called molecular bond, or is a chemical bond that involves the sharing of electron pairs between atoms. That is sharing the electron pair of electrons between two atoms is called covalent bond. Covalent bonds are formed by sharing a pair of electrons between two atoms. Then these electrons pair are known as shared pair, or it is also called bonding pair, and the stable balance of the attractive and repulsive forces between the atoms when they share electrons is known as covalent bonding. Simply, the definition of the covalent bond is covalent bonds are formed by sharing a pair of electrons between two atoms. That is, sharing a pair of electrons between two atoms. Now, let us discuss about types of covalent bond. Dear friend, as we know that there are three types of covalent bond. First one is single covalent bonds. Second, double covalent bond. And then third, triple covalent bond. Let us discuss what is single covalent bond in details. Here, single covalent bond means the bond forming between the hydrogen and chlorine coming together. It is one of the example for single covalent bond. That is, let us take hydrogen. Here, hydrogen bond with the hydrogen bond with the here, that is pairing a single, that is a covalent bond formed by the mutual sharing of one electron between the two atoms is called single covalent bond. So here one hydrogen, therefore this is called as single covalent bond. That is, a covalent bond is formed by the mutual sharing of one pair of electrons between two atoms is called a single covalent bond. Now, one more example, that is HCl. Here, hydrogen and chlorine. Here, it satisfies 2, 8 and 7, 1. Therefore, hydrogen shares the 1 electrons. Hydrogen here and here hydrogen shares the 1 electron, and at the same time chlorine, it is also shares the 1 electrons to form a bond that is called covalent bond, that is single covalent bond. Therefore HCl, it is also an example for covalent bond, that is single covalent bond. Once again, single covalent bond means a covalent bond formed by the mutual sharing of one electrons between two atoms is called a single covalent bond. Next one, double covalent bond. A double covalent bond is where two pairs of electrons are shared between the atoms rather than just one pair. Some simple molecules containing double bonds, for example, oxygen, carbon dioxide, etc. Here, double bond means a covalent bond formed by the mutual sharing of two electron pairs is called a double covalent bond. That is, mutual sharing between the two pairs of between the two pairs two pairs of electron is called double covalent bond. Then the example of double covalent bond is oxygen. That is, two oxygen atoms can both achieve stable structure by sharing two pairs of electrons in the diagram. Now, let us know the diagram. Here, oxygen, that is 2 comma 6, 2 comma 6. Therefore, the structure is as follows. Here is oxygen, one element, and same oxygen. Therefore 6, that is 1 2 electrons, and here 2 electrons, then share the 2 electrons. Similarly here 2 and 2, and it is also sharing this 2 electron. Therefore here there is a formation of 2 bond, that is double bond, that is called double bond or double covalent bond. Double covalent bond means a covalent bond is formed by the mutual sharing of two electron pairs or two pairs of electrons is called as double covalent bond. Similarly, carbon dioxide also, carbon CO2. Let us discuss about carbon dioxide. Here one carbon, sorry, oxygen, and this is carbon, and this is oxygen, O, C and O. Then already you know that oxygen donate a pair of electron here. Similarly, carbon also donate a pair of electron, and here also 2 here. That is because carbon 2 comma 4, that is in outermost shell there are 4 electrons. Here 2 2 and 2 2 and here 2 2 and 2 2, that is this is 6, this is 6 and this is 4, therefore this is in between there is a double bond. So this is the forming a double bond. Once again, a covalent bond is formed, a covalent bond is formed between the is formed by the mutual sharing of two pairs of electrons is called double covalent bond. I think its concept will be cleared. Now, let us move to the one triple covalent bond. Dear friend, triple covalent bond in chemistry is a chemical bond between two atoms involving six bonding electrons or three pairs of electrons. It is also called as three pairs of electrons instead of the usual two in a covalent single bond. In other words, a covalent bond formed by the mutual sharing of the three pairs of electrons is called a triple covalent bond. Once again, triple covalent bond is formed by the mutual sharing of three pairs of electrons is called a triple covalent bond. For example, nitrogen. Here, nitrogen also share the three pairs of electrons. That is, let us consider the dot structure of nitrogen. Here one nitrogen and here another one, that is N and N. 1 2 and it donates 3 electrons to form a covalent stable element, and here also it donates 3 electrons to form a stable. Therefore bond formation is triple bond. Similarly carbon also. So this is about the bond formation in the carbon, that is single bond, double bond and triple bond. Now let us discuss about the nature of the covalent bond. That is, this covalent bond enables the carbon to form a large number of compounds, then one more, the peculiar characters of carbon is versatile nature. The versatile nature of a carbon is a especially versatile element and is found many different chemical compounds including those found in space. That is, carbon is versatile because it can form a single bond, double bonds and triple bonds. It can also form a chain, branched and sometimes rings when connected to other carbon tetravalency. Now, let us discuss about some factors regarding to the versatile nature. The most important factor is catenation. Dear friend, catenation is the binding of an element to itself through covalent bonds to form a chain or ring molecules is called a catenation, or in other words, the self-linkage property of carbon atoms through covalent bonds to form a long chains and rings are called catenation. That is the self-linkage between the carbon-carbon linkage, or the carbon-carbon linkage is called as catenation. Example, carbon is the most common element that exhibits tetravalency. Now, there are single bond, double bond and triple bond. Now, let us discuss about tetravalency. In chemistry, tetravalence is the state of an atom with 4 valence electrons available for covalent chemical bond in their outermost electron shell giving the atom a chemical valence of 4. The carbon atom is called tetravalent because it forms four covalent bonds. It forms four covalent bonds. That is, since one carbon atom requires 4 electrons to achieve the 8 electrons inert gas structure, the valency of carbon is 4. This is carbon tetravalent. For example, methane. Methane, it is also one of the simplest hydrocarbons and it shows the tetravalency in nature. Now, let us discuss about the saturated and unsaturated carbon compounds. Saturated and unsaturated hydrocarbons. Dear friend, saturated means carbon compounds having only single bond between the carbon atoms are called saturated carbon compounds. For example, alkanes. Once again, carbon compounds having only single bond between the carbon atoms are called saturated carbon compounds. Now, saturated hydrocarbons in which all hydrogen atoms and carbon atoms are bonded together with a single bonds with a single bond. For example, methane. For example, methane CH4. This is the structure, that is C 1 2 3 4 4 hydrogen. So this is a single bond that is called carbon. Methane is one of the simplest saturated hydrocarbon. Then unsaturated hydrocarbons. Unsaturated hydrocarbons have double bond or sometimes triple bonds between the carbon atoms. This double or triple bond makes unsaturated hydrocarbons even more reactive than saturated hydrocarbons, as well as have fewer hydrogen atoms bonded to carbon atoms than saturated hydrocarbons have. Once again, unsaturated means carbon compounds having double bond between or triple bond between the carbon atoms are called unsaturated carbon compounds. Example, alkene, alkyne are the examples of unsaturated hydrocarbons. Now let us discuss about saturated and unsaturated carbon compounds in details. The example of saturated hydrocarbons is first one is alkanes. Dear friend, let us discuss the what are the factors or what are the physical properties of alkanes and in details. Now, first one, alkanes. As you know that alkanes are saturated hydrocarbons that therefore contains only hydrogen and carbon atoms bonded to each other and typically follow the chemical formula CnH2n plus 2. So this is the general formula or chemical formula for alkanes. A common example is paraffin. So this is the basic information of alkane. Here, the alkane, it is one of the saturated hydrocarbons. It occurs in three types, namely straight chain, that is straight, this in the way, straight chain, straight, and then branched chain, that is branch, like this, branched chain, and then closed chain, like this, see, closed chain, see, 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 like that, closed chain. Now The alkanes can exist as gases, liquids, or solids at room temperatures. These alkanes can exist gases state also, liquid state also, and solid state also at room temperature. The unbranched alkanes, methane, ethane, propane, and butane are gases. That is methane, CH4 gases, and then ethane, C2H6, like that, propane, and then butane or gases. Pentane through hexadecane or liquids. Pentane to hexadecane. Pentane to hexadecanes are liquid in state, and they oc- occurs homologous larger than hexadecane or solids. Now, branched alkanes normally exhibits lower boiling point. Branched alkanes normally exhibits lower boiling point than unbranched alkanes of the same carbon content. This occurs because of the force called it as van der Waals force that exists between molecules of the unbranched alkanes. These forces can be dipole-dipole or dipole-induced or induced dipole in nature. The unbranched alkanes have greater van der Waals forces of attraction because of their greater surface areas. Now, solid alkanes are normally soft with low melting points. These characteristics are due to the low melting points, important points here, are due to the strong repulsive force generated between electrons on neighboring atoms which are in close proximity in crystalline solids. The strong repulsive force counterable balance the weak van der Waals of the attraction. Finally, alkanes are almost completely insoluble in water. This is one of the important points for alkanes. Alkanes are almost completely insoluble, not soluble, insoluble in water. For alkanes to dissolve in water, the van der Waals forces of attraction between alkane molecules and water molecules would have to be greater than the dipole-dipole forces that exist between the molecules. Now, friend, the alkanes are a homologous series of hydrocarbons by derived from CH4 by inserting CH2 group. So this is the important factors regarding to the, that is, bonding nature of the carbon atom, and also the saturated and unsaturated hydrocarbons, and also versatile nature of the carbon, and also the some physical properties of the alkanes. Now, this is the main video regarding to the carbon compounds and its carbon and its compounds. Thank you for watching the video. Thank you.